Everyone, today our video is about module 4 functional and logic languages. In this video covering Lambda Calculus and overview of scheme. What do you mean by a functional language? Functional programming languages defines the output of a program as a mathematical function of the inputs with no notion of internal state and thus no side effects. So, it defines the outputs of a program as a mathematical function of the input. So, functional programming languages are specially handled to handle symbolic computation and list processing applications. Functional programming is based on mathematical functions. Some of the popular functional programming languages include Lisp, Python, Erlang, Haskell, Clojure, etc. Since logic programming is based on predicate logic, targeted at theorem-proving languages, automated reasoning, database applications. The model of computation is the Lambda Calculus. So, functional programming defines the outputs is a mathematical function of the inputs with no notion of internal state and thus no side effects. Functional programming defines the outputs of a program as a mathematical function of the inputs. Program computes by applying a functional form to an argument. Programs are built by composing simple functions into progressively more complicated ones. Recursion is the preferred means of repetition. Examples of functional programming languages: Lisp, Hope, ML, Scheme, Miranda, Haskell, Erlang. These all are examples of functional programming languages. Functional programming languages are categorized into two ways. One is pure functional languages, another is impure functional languages. So, in pure functional languages, these types of functional languages support only the functional paradigms. For example, Haskell. Then it is impure functional languages. This type of functional language support the functional paradigms and imperative style of programming. For example, Lisp. So, pure functional languages support functional paradigms. Impure functional languages support functional paradigms and imperative style programming. So, these are the characteristics of functional programming. It uses immutable state, follows declarative programming model, focus on what you are doing. It supports parallel programming. Its functions have no side effects. Flow control is done using function calls and function calls with recursion. It uses recursion concept to iterate collection data. Execution order of statements is not so important. It supports both abstraction over data and abstraction over behavior. Then we will look at the origin of these functional languages. Church's model of computing is called the Lambda Calculus. So, what do you mean by Lambda Calculus? It was based on the notion of parameterized expressions, with each parameter introduced by an occurrence of the letter lambda, hence the notation's name. Lambda calculus was the inspiration for functional programming. One uses it to compute by substituting parameters into expressions, just as one computes in a high-level functional program by passing arguments to functions. Functional languages such as Lisp, Scheme, FP, ML, Miranda and Haskell are an attempt to realize Church's Lambda Calculus in practical form as a programming languages. Then next is functional programming concept. Functional programming is a paradigm of programming. A program is viewed as an expression which is evaluated by successive applications of functions to their arguments and substitution of the result for the function expression. Its origin is in the Lambda calculus invented by the Church in the 1930s. A computation is a sequence of expressions that result from the successive evaluation of sub-expressions. Then we will look about functional programming concept, the significant features, first class and higher order functions, implicit and parametric polymorphism, bufferable list facilities, structured function returns, fully general aggregates, garbage collections. The functional programming concept, which are the we will look detail about this concept. What is first one is no side effects. Computation in the functional programming has no side effects. The only result of a functional computation is the computed value, and there are no additional changes that can take place during computation. Functional programming does not support variable assignment or state mutation. This is functional programming contains higher order functions. What do you mean by higher order function? A higher order function takes a function as an argument or returns a function as a result. Functional programming requires that functions be first class, which means that they are treated like any other values. Here the functions can be passed as arguments to other functions. Functions can be returned as a result of function. Function can be no names. Church's model of computing is called Lambda Calculus. So, it is based on the notion of parameterized expressions. In this, each parameter is introduced by an occurrence of letter lambda. And Lambda Calculus was the inspiration for the functional programming. And in previous question papers, we say questions are asked, what is Lambda Calculus? So, Lambda Calculus includes three different types of expressions. E is equal to x variables, where E1, E2 represents function applications. Lambda xe function creations. Lambda xe is called a lambda abstraction, where E is known as lambda expression. Function creation, the notation lambda x dot e to denote a function in which x is a formal argument and e is the functional body. These functions can be of without names and single arguments. This is the expression of lambda calculus and its syntax. Please study all this, because these are the questions asked in previous question papers. Then function application, Church uses the notation E1 dot E2 to denote the application of function E1 to actual argument E2. And all the functions are all single argument. To create a function in scheme, one evaluates a lambda. So lambda x is equal to star xx, it is a function. The first arguments to lambda is a list of formal parameters for the function. In this case, the single parameter x, the remaining arguments, one in this case, constitute the body of the function. A lambda expression does not give its function a name. Example in scheme lambda x star xx3. So how it is applying? 3 is applying. You use the star xx. So star means multiplication symbol. X is 3. So expression is evaluated as 3 into 3, that becomes 9. The lambda expression is the function itself, which is nameless. A lambda expression specifies the parameter and the mapping of the function. Here we can see lambda expression is given plus xx2. Here we can it is evaluated as 2 plus 2, that is equal to 4. Lambda expression star x42 23. So the value becomes what? 65. Lambda expression x5 plus x5. Here also the value becomes 65. This is how the lambda expression is expressed and evaluated. Lambda x1 x2 star minus x1 x2 minus x1 x2. How it is calculated? 2 minus 5. So it gives to 49. Then next we will go through scheme, overview of scheme. This origin and scheme interpreter, primitive number functions, defining functions, numeric by predicate function, binding, control flow, list functions, difference between let star, let rect, difference between EQ, EQV, equal. These are the portions that should be covered. Scheme language is developed in the mid of 1970s. It is invented by Guy Lewis Steele Jr. and Gerald J. Sussman. Emerged from MIT, it is originally called Schemer, shortened to Scheme. Scheme interpreter is a read, evaluate, write infinite loop. The interpreter repeatedly reads an expression from standard input, generally typed by the user, then evaluates that expression and prints the resulting value. This is how the scheme interpreter is working. Read, evaluate, write. Then expressions are evaluated by eval functions. So most scheme implementations employ an interpreter that runs a read, eval, print loop. So he is plus 3, 4. If we are given an expression, the interpreter will print 7. That is 3 plus 4 equal to 7. If the user types 7, the interpreter will also print 7. The most scheme implementation provide a load function that reads and evaluates input from a file. So how the load expression is using? The syntax is load, and in double quotes we are giving the name of the program. Here it is used as my scheme program. So the load function that reads input from a file. Scheme uses Cambridge Polish notation. That is a variant of prefix notation for expressions. Parentheses indicate a function application. The first expression inside the left parenthesis indicate the function. The remaining expressions are its arguments. Plus 3, 4. When it sees the parenthesis, the interpreter will call the function plus, passing 3 and 4 as arguments. The plus 3, 4 is equal to evaluate to 7. One can prevent the scheme interpreter from evaluating a parenthesis quoting expression by quoting it. Quote plus 3, 4 is equal to plus 3, 4. Here the result is a 3-element list. Quoting is specified with a special shorthand notation consisting of a leading single quote mark. Then quotes 3, 4, that is plus 3, 4. Here this symbol means evaluates 2. This symbol is not a part of the syntax of symbol itself, scheme itself. Scheme includes primitive functions for the basic arithmetic operations. These are plus, minus, star and division, slash for add, subtract, multiply and divide. If star has no parameters, it returns 1. If plus is given no parameter, it returns 0. Plus add all parameters together. Star multiplies all its parameters together. In case of subtraction, the second parameters are subtracted from the first. Overview of scheme primitive functions. Here we can see the plus 5, 7, 8. It evaluates to 20. Minus 5, 6. It is minus 1. Star 3, 7. It becomes 21. And we can see minus 15, 17, 2. The expression is 6. Minus 24. Star 4, 3. The expression gives 12. And plus, just give a plus, it evaluates to 0. So you should study this evaluation expression of scheme. Overview of scheme primitive functions. The primitive functions in scheme are a, b, s, square, sqrt, remainder, min, max. Maximum of 2, 3, 4. It gives the maximum value. Here it is 4. Minimum value of 2, 3, 4. It is evaluates to 2. SQRT means square root. Square root of 4 is 2. Then absolute value, that is can be calculated by ABS. That is absolute value of minus 5 is equal to 5. Then remainder of 5, 3, it gives 2. User-defined functions can implement their own type checking using predefined type predicate functions. The names for all predefined predicate functions that have words for names end with question marks. Two Boolean values are hash t and hash f. So Boolean x means if x is a Boolean. Character x means if x is a character. String x if x is a string. Symbol x is a symbol. Number if x is a number. Pair x is x a pair. If list x if x is a proper list. So a scheme program is a collection of function definition. A scheme, a nameless function includes the word lambda called lambda expression. For example, lambda x plus xs is a nameless function that returns the square root of the numeric parameter. So lambda of x plus xx 8 gives what? 16. Okay, 8 plus 8, 16. Here x is called a bound variable within the lambda expression. It never changes in the expression after being bound to an actual parameter value at the time evaluation of lambda expression begin. Scheme provides a special form function define. So it is used to bind a name to a value and to bind a name to a lambda expression. Define is called a special form because it is interpreted in a different way than the primitives. So we will look how the define is using. Define simple expression. Define pi 3.14159. Define 2 pi means star 2 pi. If pi is typed, scheme interpreter will display the number 3.14159, and if 2 pi is typed, it display 6.28318. So syntax of define is define function name parameters, then bracket expressions. Define square number star num. If interpreter evaluates for square 5, it gives evaluates to 25. Define double x means star 2x means double 4, that is evaluates to 8. Define hypotenuse lambda AB square root plus star AA into star BB, that is hypotenuse 3, 4, that is given evaluates to 5. 3 binding constructs. Let rect give scheme block structure. So this expressions is previously asked in question papers. So the syntax of 3 constructs is identical, but they differ in the regions they establish for their variable bindings. In let expression, the initial values are computed before any of the variables become bound. In a let star expression, the valuations and bindings are sequentially interleaved. In let rect expression, while the initial values are being computed, all the bindings are in effect. So we will look at the expressions, how it is using. The syntax is let variable init expression or lambda variable expression init. Let x2 y3 star x5, that is given as evaluates to 6. Let x plus 1 0 y2 plus x5, that is evaluates to 3. A lambda expression does not give its function a name. It is done using let or defined. Let establish a local variable binding. Let id expression id1 expression 1. Let x23 y42 the plus xy is equal evaluates to 465. Let a3 be for square lambda x star x plus square root of plus square a square b. When it is evaluated, it is given as 6. The special form let takes 2 or more arguments. How this in above we see the 5 is coming. How it is coming? That is square of a. What is a value is 3. Square of b means what is value? B is 4. So 9 plus 16, that it becomes what, 25. Then it becomes square root of 25 becomes 5. That is how the expression evaluates 5. The first of this is a list of pairs. In each pair, the first element is a name and second is the value that the name is to represent within the remaining arguments to let. Remaining arguments are then evaluated in order. The value of the construct as a whole is the value of the final argument. The special form let takes 2 or more arguments. The first of this is a list of pairs. In each pair, the first element is the name and the second is the value that the name is to represent within the remaining arguments to let. Remaining arguments are then evaluated in order. The value of the construct as a whole is the value of the final argument. So let x2, y3, let x7, so it becomes 35. The one problem with let is the initial values are computed before the variables become bound. For example, this doesn't work since x is not outside the body. Let x3 y plus x1 plus x5. To get around this problem, scheme provides us with let star. So let star x3 y plus x1 plus x5 values to 7. So that is another is overview of scheme with a nested scope with the let star. Let star construct in which names becomes visible one at a time, so that later ones can make use of earlier ones but not vice versa. Each initial value expression can be used the previous binding. Special form let star is variable end in expression. Let star is similar to let, but the bindings are performed sequentially from left to right, and the region of binding is that part of the let star expression to the right of the binding. Here we can see the problem. It is evaluates to 70. Then another use is how letrec is used. Letrec provides a way in which names becomes visible all at once at the end of the declaration and supports the creation of recursive functions. The syntax is letrec variable init expression. The inits are evaluated in some unspecified order. Each variable is assigned to the result of the corresponding init. Expressions are evaluated sequentially to the extended environment, and the value of the last expression is returned. We can see the factorial of 5 is evaluated using letrec expression. It gives 120. This is how the letrec operations are working. Then scheme uses two different constructs for control flow. Scheme two-way selector named if has three parameters, a predicate expression, a then expression, and else expression. Syntax if predicate, then expression, else expression. This is how the example if greater than 5 to yes, no, return yes, because 5 is greater than 2. Then another expression greater than 5 to plus 5 to minus 5 to, it returns 7. So in this plus 5 to is calculated, that is 7, and whichever one is greater, that is returned. Minus 5 to we can get as 3 minus 3, and whichever value is greater, that is returned. That is how the 7 is getting output. Then scheme uses multiple selector. The multiple selector is using the expression COND, that is conditional expression, condition, prediction 1 expression, predict 2 expression, prediction n expression, else expression. The predicates of the parameters are evaluated one at a time first until one evaluates to hash t. If none of these predicates are true and there is an else, its expression is evaluated and the value is returned. Scheme multiple selector is here we can see this is how the scheme multiple selector is using. Define compare x, condition greater than x5, x is greater than y, less than x5, y is greater than x, else x and y are equal. Condition greater than 5 to greater, less than 5 to less, else equal. Then it uses three functions char, cdr and cons. Char means it takes the list parameter and returns the first element of that list. Okay, so char abc means it returns first expression, which abc list, which one is first, a, then it yields a. Then char abcd we can see as a list. AB is one list, CD is a list, so the first element of the list is AB, so the output is AB. Then CDR expression, it takes a list of parameter, return the list after removing the first element. Okay, so after removing the first element in CDR ABC, first one is what, A, that is removed, remaining is BC, so that is yields BC. CDR ABCD, here first list is removed, that is AB is removed and remaining is CD, so it yields CD. Then it means construct the list. It takes two parameters, the first of which can be either an atom or a list, and the second of which is a list. Returns a new list that includes the first parameter as its first element and the second parameter and the remainder of the list. Cons A, B, C returns it joins the list and becomes ABC. So 3 basic list operations: car, which returns the head of the list; CDR, that is scooter, which returns the rest of the list; and cons, which joins a head to the rest of the list. Car 234 is 2, CDR 234, that is 34, cons 234, it returns 234. This is how the car CDR cons expressions are using. These are all questions that are asked in previous question papers. Students, please work out all these expressions. So lambda expressions form is based on lambda notation. Lambda L, car L. L is called bound variable. Lambda expressions can be applied. Lambda L, car L, ABCD returns A. User interacts with the scheme through read, eval, print, loop operation, RAPL. Scheme expressions, also called an S expression or symbolic expression, are either list or atoms. A parenthesized string of symbols is called an S expression regardless of whether we think of it as a program or as a list. An unevaluated program is a list and can be constructed, deconstructed, otherwise manipulated with all the usual list functions. List and scheme are homoiconic, it means self-representing. Another important function is eval function. Scheme provides an eval function that can be used to evaluate a list that has been created as a data structure. In the declaration compose takes as argument as a pair of functions f and g. It returns the result, a function that takes a parameter a value x, applies g, then applies f, and finally the result. So in this expression it gives 2. Features of eval function. When passed a number or a string, eval simply returns the number or string. When passed as a symbol, it looks the symbol up to the specified environment and returns the value to which it is bound. When passed a list, it checks to see whether the first element of the list is one of the small number of symbols that name so-called primitive functions built into the language implementation. Then another is apply function. This function apply takes 2 arguments, a function and a list. When passed a function f and a list of arguments L, apply inspects the internal representation of f to see whether it is primitive. If so, it invokes the built-in implementation. Then 3 expressions: equal, EQV, and EQ. So EQ is a pointer comparison. It returns #t if its arguments literally refer to the same objects in memory. 2 symbols that look the same are EQ. 2 variables that refer to the same object are EQ. EQV is like EQ expression. EQV returns #true if the arguments are EQ or if its arguments are numbers that have the same value. EQV does not convert integers to floats when comparing integers and floats through. So these are important topics: equal, EQV, EQ. These are all questions asked in previous question papers. EQ returns true if its arguments have the same structure. 2 objects that are EQ are both EQV and equal. 2 objects that are EQV are equal but necessarily EQ. 2 objects that are equal are not necessarily EQV or EQ. EQ is sometimes called an identity comparison and equal is called an equality comparison. So these are the expressions, how equal, EQV and EQ is using. Define clam star list 1, 2, 3. Define octopus clam. Clam and octopus refer to the same list. EQ clam, that is same, that is true, represents EQ clam octopus #true. EQ got 1, 2, 3, 1, 2, 3 #false. EQ 10, 10 true. EQV 10, 10 returns true. EQV 10.0, 10.0 true. EQV 10, 10, 1, 10.0, 10 false. Equal clam star 1, 2, 3 returns true. EQL 1, 2, 3, 1, 2, 3 returns true. This is how the equal and EQV operations are applying. Then another equality identity is member MQ. So to search for elements in a list, we are using the functions memq, memb, member. Take an element and a list as search function arguments are returned to the longest suffix of the list, beginning with the element. memq zxy zw returns zw, memv zxy zw returns false, mem zxy zw returns zw. The memq, memv, member functions perform their comparisons using equal, eqv and eq. They return hash false if the desired element is not found. So these are the search for elements in a list. Then function ASSQ, ASSV and ASSOC search for values in association list. As an A list, what is A list? It is association list. Is a dictionary implemented as a list of pairs. The first element of each pair is a key of some sort. The second element is the information corresponding to that element. ASQ, ASV and AS take a key and an A list as arguments and return the first pair in the list. If there is one whose first element is EQ, EQ, EQ respectively to the key. If there is no matching pair, hash false is returned. I will come with the next video with the strictness and lazy evaluation. Till then, bye. If any doubts, you can ask us comments. Till then, bye.